objective of this experiment. 1. To investigate the functional relationship between fall height and fall time. 2. To determine the acceleration due to gravity. G. By studying the motion of a freely falling body.
For apparatus, we use 200-meter long ruler, ping pong ball, and timer. Next is procedure. First, two 100-meter long ruler was put on the wall as in the figure 3.1. Second, a ping pong ball was dropped from 150 meters. Third, the time when the ping pong reached the ground was measured by a timer. The time taken was recorded. 4. Step 2 and 3 was repeated 2 more times to obtain the time average values. And lastly, step 2 to 4 was repeated by using different height of fall. Analysis number 1 from A. The true plot graph for a height of fall as a function of falling time, and B. Hash of fall as a function of the square of falling time. Number 2. Using the height of fall as a function of the square of falling graph, determine the gradient slope of the graph and calculate the value of G. Number 3. Calculate value of uncertainty of G. Number 4. Calculate the percent difference between the value of G calculated in part 1 above G experiment and the standard value of G standard within 9.81 ms square, and this is the percent error experiment value. The discussion of this experiment is the error could happen when the release start point are not accurate. Therefore, make sure the ball placed in the right release point to avoid any error.
This trial error may be caused by a slow timer to press the stop button after the ball drop. This error can be minimized by taking a set of readings by different observers. Experimental error can also be caused by random error. In this experiment, to test the acceleration due to gravity by studying the movement of a freely falling body. To ensure that this experiment get correct and accurate result, the observer and the timekeeper need to focus while watching the ball release and when the ball fall. This experiment need to be repeatedly several times to get satisfactory result.
In conclusion, experiment 3, which is measuring gravitational acceleration, considered a successful experiment, will achieve objectives that we target for this experiment. First, the functional relationship between height of fall h and falling time t have been investigated. We need to use this formula, which is S equals ut plus 1 over 2 at squared, to get the functional relationship between those two. Other than that, we use mean difference of height to investigate this case to get the average reading. Next, the coordinate h as a function of time, we use formula h multiplied to t equals 1 over 2 gt squared to figure it out till achieve the succeed of objective. Second, the acceleration due to gravity g by studying the motion of a freely falling body was determined. Basically, gravity unit was 9.81 ms power negative 2. We conclude the formula that we use and achieves what our objective need. The acceleration had different number due to gravitational factor. With that, in summary, experiment 3 can consider as a successful experiment.
Objective experiment 4 is to determine the coefficient of static friction of different surface.
For apparatus, we used wooden block, 3 rubber, 50 gram of masses, 10 Newton spring scale, and a tabletop. For procedure, first, the mass of wooden block was measured as recorded as M. Second, the apparatus was set up as shown in figures 1.1. Third, the tabletop had been short stable and horizontal to the ground. 4. The spring scale and the wooden block had been attached and had been placed horizontally on the tabletop. The rubber side of the block was short face downward. 5. A mass equals to 50 gram mass was placed on the wooden block. 6. The spring is pulled slowly. The spring scale's reading was recorded once the block started to move. The value as Fs were recorded and tabulated in table. 7. Step 4 until 5 was repeated for 3 trials. A. Another 50 gram mass was added on the wooden block and step 5 to 6 were repeated. The steps were repeated until total of mass equals to 50 gram mass was placed on the wooden block. Lastly, step 1 until 8 repeated. This time, the rubber side of the block had been short, facing upward. The data was to tabulate in table.
For analysis, 1. Draw and label the free body diagram of the wooden block. 2. Plot graph of static friction force Fs against normal force N for the rubber surface and non-rubber surface. 3. Use the gradients obtained from the graph to calculate the coefficient of static friction.
Question 1. Anti-lock uses the ABS prevent where lock up and out of control skid in braking situation where the wheel on a non-ABS equipped vehicle would lock up. ABS will generally provide shorter control stopping distance. Question 2. Rubber surface toward the floor has the highest coefficient. Yes, it is. The smoother the surface, the higher the friction will be. The resistive force of friction determines the coefficient of static friction. Question 3. The mass undergoes stop and go motion. Because of friction, the velocity is decreasing.
Friction is an opposite force that resists the motion or attempt motion of one surface across another surface. Friction depends on the material of both the object surface and weight. The frictional force are presumed to be proportional to the coefficient of friction. The amount of force required to move an object starting from rest is greater than the force required to keep it moving at constant velocity once it is started. Therefore, static friction is greater than kinetic friction. It is better when one person pulls the block 3 times because the force used in this experiment while pulling the block is called inconsistent. As a result, the data is more accurate and less false.
in our everyday motion, because without it, any body in motion will not stop. Friction is a force that opposes motion. We define two kinds of friction, which is static and kinetic. We also experience both of them in the experiment. We try to avoid static friction by giving a slight push to the block so it can have kinetic friction, because when a body is in motion, static friction is less. We have verified that the coefficient of friction is constant whether we increase the weight of the block and the weight of the mass hanger. A graph presented also explains that the relationship between the slope and the coefficient value of friction are the same. This is also verified experimentally when comparing the results taken from parts A, rubber surface towards the floor, and B, non-rubber surface towards the floor. The interpretation of the graph is that the weight of the block plus the weight X is directly proportional to the weight of mass hanger plus weight added. In other words, x-axis increase as y-axis increase. We prove that the area in contact with the surface does not affect the coefficient of friction. This is done in the first part of the experiment in trial 1 and trial 3. It is necessary to observe uniform motion through a constant speed, or motion kinetic friction is essentially constant. Newton's first law of motion states that when an object experiences no net force, then its velocity is constant. No matter what the vertical and horizontal distance is used, angle of repose will just remain the same. The percent difference can be the cause of human errors, such as wrong readings of the measurements in terms of the angle and the vertical hinge. And of course, we may think that the block is in uniform motion, but